Okay, you guys need to remember your special triangle knowledge from back in the day. Okay. Luckily for you, these two charts are given to you on the formula sheet of the end of course test. So you can use them. You just need to remember how to use them. So in this case, we've got the 12 right there. That's like the x. So that means 12, 12, and what's the hypotenuse going to be? 12 root 2. All right, is this mystifying to you guys? So the value of x, that's going to be 12. And the value of d is going to be 12 root 2. Okay, any questions so far? Now, looking at this one, we know this angle up here is going to be our 60 degrees. Okay, so notice this 6 radical 3 is across from the 60. So looking at our diagram here, across from the 60 should be x radical 3. So that means the x part must be what? Here I have 6 radical 3. This is in the same position as x radical 3. So what's x then? So x must be 6. That means the short leg over here must be 6. Okay, so it's 6 radical 3. Well, if the short leg is 6, what's the hypotenuse? Then the hypotenuse must be 12. Remember, the hypotenuse is double. Anyway, so P here turned out to be 12, and K was 6. Okay? Look at problem number 3. Diagonal of a square. Okay, so we have a square. Stop with the tapping, please. Thank you. We're going to deal with the diagonal of this square. The diagonal is 18, so there's my 18 diagonal. Well, because it's a square, how many degrees is this right here?
45.
That's 45, 45. That's good because we can use our chart, our 45 degrees. Look at the hypotenuse of this chart. What do you see? X radical 2. On our hypotenuse, that's 18. That's where we get this little equation. X radical 2 must equal 18. That 18, that x radical 2, they must be equal to each other. So I already heard several people say what I'm about to do next, which is divide. I hear people saying, let's divide by radical 2. That turns out to be what? That turns out to be 9 radical 2. Let me switch colors real quick. Okay, that's not the answer to the question though, is it? Okay, that just gives us the sides, 9 radical 2, 9 radical 2. We're supposed to find, correct, the area. And somebody was asking me earlier, I think it was you, how do we find the area of a square? No, that's triangle. Just base times height. So 9 radical 2 times 9 radical 2. What does that make? That makes 162. Any questions on number 3? Length and width of a rectangle is given here. It's like this. Okay, this is a rectangle. The height is 7. The length is 24. So here's our rectangle. We're supposed to find the length of this diagonal. Okay, so I'm going to call that x because that's what we're supposed to find. I already hear Marco saying what to do. Tell me again. Yeah, let's use the Pythagorean Theorem. Plain and simple. A squared plus b squared equals c squared. So we're talking about x squared equals 7 squared plus 24 squared. We're going to wind up doing the square root of this. I think it was 625 once you added it all up. So I think it turns out to be 25 based on my last class. Any questions so far? Is this coming back to you guys? No? That's not good. I mean, people that said no. I am here before school and after school. If anybody finds themselves lost, feel like you're drowning, feel like you won't do very well on the EOCT, come in. We'll go over this together. Oh yeah, I forget that yours is not in color. Okay, so let's see, what's next? Look at number 5, perimeter. What does that word perimeter mean? It's all the sides added up. So the perimeter of this equilateral triangle is 36. So everyone should have drawn a picture. Everybody draw a picture. Make this bigger. Whoa! ¿Qué pasó? Okay, so here's my triangle. If the perimeter is 36, what's the length of each side? Each side must be 12, agreed? Okay, so look, here's my altitude that I'm supposed to find. Right, I heard Chrissy say, look, if this is 12 down here, that means this must be 6 and 6. Okay, can you tell me about degrees? How many degrees are the corners? Right. Can you guys know this is going to be a 30, 60, 90 triangle? All right. Who needs me to explain how I knew it was a 30, 60, 90 triangle? It's equilateral. Do we know the total degrees in a triangle? What is it? 180. Total degrees is 180. So 180 divided by 3. That's 60. That's how we knew that this would be 60.
Can you still use Pythagorean Theorem?
Yes, you could still use the Pythagorean Theorem. Okay, we're supposed to find this height. I'm going to call it x. If you use your special triangle knowledge, you just automatically know it because that's the long leg. And if the short leg here is 6, then the long leg must be, say it again, HT.
6 square root 3.
The long leg must be 6 square root 3. Okay, so that's the altitude for number 5. Any questions about that? Yes, my friend. Okay. Now, watch this very carefully. Look at number 6. Merit. See this angle right here? I'm going to put a smiley face there. Okay. Merit is telling me that the smiley face angle is 30 degrees. Did you guys all know that that angle was going to be 30 degrees? Yes. All right. Remember about the Z angles. Can you guys see a Z when you look at this picture? Yes. It's a Z. It's going like this.
It's like Zorro.
Okay? Anytime you have a Z angle like this, the two corners in the Z will always be the same degrees. So if this is 30 degrees up here, then this is also going to be 30 degrees down here. All right, that was critical. We're supposed to find the vertical distance from the lower floor to the upper floor. So we're supposed to find this distance right here. Okay, so basically we have a right triangle. Again, we could use our special triangle, our 30, 60, 90 triangle knowledge. This that we're trying to find, this vertical height, that's the short leg. Looking at our chart, what's the relationship between the short leg and the hypotenuse?
Double.
It's double. The hypotenuse is double. The short leg is half. Okay? So, look at the hypotenuse in our picture right here. How long is the hypotenuse of this? 70.
70.
If the hypotenuse is 70, what's going to be the short leg over here? 35. First. Okay? So that's the answer right there. 35. 35 feet. the hypotenuse is double the short leg. The stairs are the hypotenuse. So we do half to get the short leg.
Oh, I got it.
Do you see it?
Yeah, sorry.
The vertical distance, that is the short leg. So once we take that half, we're done. Okay. All right. On the back. Look at number 7 with me. Thank you. Looking at number 7, we've got the sine. Now, sin. No, it's pronounced sine. I should make a sign, like one of our posters. I don't know why I don't have a poster up here. But you will be given these 3 little formulas just like this. Okay? So let's just use them. So problem number 7 mentions the sine function. What is the definition of the sine function? Opposite over hypotenuse. Okay? Now look at this picture. Look at theta. Alright, looking at this angle, what is opposite and what is hypotenuse?
X over 15.
Opposite is x, the hypotenuse is 15. So the sine of theta should equal x over 15, am I right? Now, I can just stick that on the end of here, because they say the sine of theta equals 5 over 6, but we just found that it will equal x over 15. So we have a new equation. 5 over 6 must equal x over 15. Do you follow that logic? Merritt, did you follow that logic? Really? Sort of. I thought I heard a sort of in here. Okay, let me go back. Let me start at this. If I just asked you to set up sine theta, what would you have said that it is? Like, what's the definition of sine? Opposite over hypotenuse. So looking at this angle, what's opposite and what's hypotenuse? Okay, so would you agree that sine theta should equal x over 15? Okay, so here they already had that sine theta equals 5 over 6. So they're saying sine theta equals 5 over 6. We're saying sine theta equals x over 15. Well, both of those things have to be true at the same time. So if sine theta equals 5 over 6 and x over 15, that only will make sense if x over 15 equals 5 over 6. They all have to be equal, since they both equal sine theta. Does that make sense? Yeah. Okay. And then once you have it set up, I'm betting that almost everyone in here would be able to solve it from here. How would I solve this little equation? Cross multiply. Were you guys thinking that? Let's cross multiply. So I hear Hollison saying 6x, and then of course we'll do 15 times 5. Okay, so 6x equals 75. Divide by 6. Answer? You can give me a decimal. 12.5 or 25 over 2, something. Either one. Any questions about number 7? All right, look, number 8 should work the same way. See where the theta is? Up in this corner? Because this is where the theta is over here. Watch where I'm going to draw my triangle. I need to make sure I draw my triangle around the theta for the problem to work out. Let me change colors. I think I'll use green this time. Okay? So I'm using this triangle right here. I'm looking at this triangle. Whoa, messed up. Okay, n and 14. That's what I need to set up. Everybody look at this n. do you think the n value is going to be the horizontal value or the vertical value?
Horizontal.
McDonald says it's going to be the horizontal value. Why is he correct?
Because it's the x.
Because it's the x value. And the x value, of course, will be horizontal. All right, Siobhan, does that make sense? The n should be horizontal? Christy, you're following? So that means the 14, that's the y value. So it should be the vertical length. Okay? Now, look at that picture. Look at the theta. The problem already mentions tangent. So let's talk about tangent. What would be the tangent of theta looking at this picture? Because what's the definition of tangent? Opposite over adjacent. So looking at theta, what's opposite and what's adjacent?
It'd be n over 14.
N over 14. From the perspective of the theta, opposite is n and 14 is adjacent. All right, who needs explanation on that? Okay. Siobhan, is this making sense?
Yeah.
Are you sure? That sounded hesitant.
No, it is.
Please. And the rest of it is the same as before. We would cross multiply and get the answer. Okay? For now, I'm moving on. I'll leave you to finish that part on your own. Okay, look at problem number 9. Okay, look at problem number 9 with me. Thing number 1 that I need you to understand. When we start talking about sine or cosine or tangent, these functions are only defined for right triangles. We have to be talking about right triangles. So everybody pay attention. Everyone focus. This small triangle is here. I'm talking about this triangle, the 4 small triangles. Are any of these small triangles right triangles? No, we do not know that this is a right angle here at E. None of these look like they're right angles. So, if we are dealing with either of these 4 small triangles, we cannot use tangent, sine, and cosine. So, are there any right triangles in this picture? Where are they? So, like, for example, Maurice said D, B, C. The big triangles are right triangles. So that's a key to this problem, is not to look at the small triangles. The right triangles are the bigger triangles. So we're looking for the one that would give us a sine of 12 over 13. So let's see what we have. Look at triangle ACD. Okay? No, not triangle. Angle ACD. ACD. That would be this angle right here. Okay? Now remember, I need the big triangle, not the small triangle. So if I'm talking about that angle, then this is the triangle that I would be looking at. Okay? So looking at that triangle, what would be the sine of this angle that I've just marked? I better talk to a specific person. Okay? Edgar, looking at this angle that I just marked. Oh, you know what? Let's put some more numbers on here. See how we have the 12 and the 5? What's a rectangle? So what's over here? 5. And what's down here? 12. We should probably do this too. This hypotenuse. How would I find this hypotenuse? Pythagorean Theorem, Martin said. Okay, Pythagorean Theorem, right? If we did that off to the side,
It's 13.
it's going to turn out to be 13. Can I trust that you guys can do the Pythagorean Theorem and the diagonals? Why did I put 12? The diagonal is going to come out to be 13. I should erase it. Okay, so those are the sides of the triangle, the 5, the 12, and the 13. Now, back to Edgar. Looking at the angle that's marked, can you tell me what the sine of this angle would be? Okay, that's one. The sine would be 5 over 13 for A. Because looking at the angle, 5 is opposite, 13 is the hypotenuse. 5 over 13. You got 2, Maurice. Next one's detention. So it's not A because it's supposed to be 12 over 13, not 5 over 13. Are you with me? Don't say the answer. This pen is too thick. Okay, so it's not A. Let's talk about C. Angle BAC. Let's see. BAC. Is basically the same thing. Right? BAC would just be this triangle up here, yes? Okay? But again, the sine would be opposite over hypotenuse. Again, that would be 5 over 13. Alright? So that's not the answer either. So we're down to the last two. Look at angle DEC. Well, DEC is this angle in here. Is that even going to be part of a right triangle? No, that's one of those small angles. So that's not going to work immediately. So the answer must be D, but let's go ahead and look at it specifically and make sure we fully understand. Alright, let me clean this up a little bit. Okay, so looking at this last one. Angle DBC, so DBC. That's this angle up here. I have to look at the big triangle. So I have to look at this guy. Alright, that's the angle that I need. That's the triangle that I'm focusing on. So looking at that triangle, the sine of this angle would be opposite over hypotenuse. That would be 12 over 13. So that's the right one. That's the one that matches. So the answer is D. Did you guys follow that? This is a really common EOCT style question. So this is really important. So please raise your hand if you felt like, yeah, you understood number 9. If you saw it on the EOCT, you're getting it right. Raise your hand if you understood what we just did. I need the feedback. Okay. Put your hands down. Wait, so you didn't understand, Maurice? Thank you. No. Tristan. Okay. Yes. Okay. Do you understand that we were looking for the angle that had a sine of 12 over 13? Okay. Do you understand that angle DBC is this angle up here in the corner? Now, so look at this picture. Can you tell me what the sine of that angle would be? Sine of that angle. Okay, you see that that matches what we were looking for. Therefore, that one's the answer. If you looked at any of the other three that we crossed out, we were getting 5 over 13. Stuff like that. Stuff that wasn't the right answer. All right, moving on. Okay, look with me at angle P. So angle P, I'm looking right here. So see if you can think like me. For all of these problems, you should be looking at 3 things. Look at the thing that you're looking for, and look at the 2 things that you're given. That's 3 things. So in this case, I'm looking for angle P. I'm given 13 and 8. Those are the three things I have to deal with. Based on those three things, you should be looking at sine, cosine, and tangent and asking yourself, which one of those three functions fits these three pieces of information?
Sine.
I hear sine being said. Now, the rest of you that were silent,
It's inverse sine, right?
we'll see. Okay? Looking at that angle, 8 is opposite and 13 is hypotenuse. Opposite, hypotenuse, sine function. Okay? Does everybody see why we're about to use the sine function?
Yeah.
Now, I think I like what Maurice was saying, though, as well. We would start off saying this. Sure, sine of angle P is equal to opposite over hypotenuse. So we'd start off with this equation. But it's been a long time, but do you guys remember how we used to get the angle out of it?
No.
Don't remember? Maurice remembered.
-1. Yeah, you got -1.
The inverse trig functions. When we wanted to get the angle out, we would say inverse sine of the answer. That gives you the angle. The inverse trig function gives you the angle. That's why the answer number 10, we're going to write inverse sine of 8 over 13. Okay?
What if you wanted to solve it?
You could solve it, but on this paper, I don't want to see it on the line. Because most likely, on the EOCT, that would be the multiple choice. But if you do you know how to put this in your calculator? Okay. Now I understand what you're asking me. That's a good question. All right, look, you guys. They may ask you for the actual answer on the EOCT. So, yes, you do need to know how to type it in your calculator. Inverse sine 8 over 13. So let's review that real quick. Who remembers how we do this on our calculator?
Or what? Which one?
Inverse sine. Blurt it out, Brown.
Second sine.
Yeah, second sine.
Second sine.
Second sine.
If you hit the second button and then hit sine, that makes your inverse. And then we could go n over d button. What was it, 8 over 13?
Yeah.
8 over 13.
37.
Okay, 37.8, 37.98, whatever. That's it right there. Okay, so I should have done that in my other class as well. Please do know how to type it in your calculator, just in case they do ask you for the actual answer. Okay, let's go back. I'm going to leave you to find number 11. I'll leave you to do that on your own as part of your homework. How would I find PD? I would do the Pythagorean Theorem. A squared plus b squared equals c squared. Again, I'm going to leave you to do number 12 on your own. Just do the Pythagorean Theorem. I'll give you that hint. Okay, moving on down. Angle J. Angle J. Okay. What's the quickest way to find angle J?
Add those two together.
Subtract.
Okay. You guys know that what's the total amount of degrees in a triangle? 180 is the total amount of degrees in a triangle. So you could start with 180 and subtract 90 and subtract 35, and that will give you the answer. And that's pretty quick. There's a one-step quicker way. Okay, Maurice is saying, look, in a right triangle, we've always got the 90. So we can forget about that and just do 90 minus 35. Okay, so if you've got a right triangle, you don't really have to go all the way back to 180. You can just do 90 minus the angle that you've got, and boom, that's the other one. All right, Edgar. Sit up, brother. You're making me sleepy.
How come the answer is across the
Which one are you talking about?
on the answer key, like how come the answer is across the 13?
It's like matching. It's supposed to be scrambled up. Okay, so number 13, what was it, 55? Okay, 13 was 55 degrees. Any questions so far? Did anybody do number 12 and or number? Yes. What was the answer to number 12? Square root of 105. In case anybody was wondering. Okay, no decimals. Give me the expression. Okay, moving down to number 14. JK. Let's see. Let me erase a little bit. Yeah, I'm just recording. I'll edit it later, but yes, everything's recording. That's all right. Okay. JK. So I'll put an X here because this is the thing that we're trying to find right now. Whoa, come back. Where'd it go? Okay, this is the thing that we're trying to find right now. But once again, focus your eyes on three things. The thing that we're trying to find and the two numbers that we're given. So as you focus on those three things, I ask you, which function should this be reminding you of?
Cosine.
Right. I'm hearing two different people mentioning cosine. Okay? Why? Why cosine? Right. Looking at the 35, 9 is adjacent, x is hypotenuse. Okay? That's cosine is adjacent over hypotenuse. Say again? Why am I using 9? You're always, in these problems, you're going to use what you're given. So when you look at that triangle, we're given two numbers, 35 and 9. So we're definitely going to use those two pieces of information, because that's all we've got. Does that make sense? Okay? So 35 and the 9. I mean, look back at the previous problem that we did. We used 8 and 13. Those are only two numbers we had, so we used them. Yeah. Okay, so yeah, looking at the picture below, what two numbers am I going to use on the bottom triangle, Siobhan? 55 and 5. Whatever the two numbers you got, use them. Okay, so back to this one. We decided that we're going to go ahead and use cosine. So here we go. So cosine of 35. What's the definition of cosine? Adjacent over hypotenuse. So what goes in the top, what goes in the bottom? So what, like x9? So we're going to do 9 over x. All right, now focus. Mr. Bahena, or really anybody, do you guys remember the shortcut that I taught you a long time ago? Ronnie, do you remember the shortcut of how to solve this in one step? Yes. Do you guys remember what Ronnie remembers? That we could switch the denominator. You weren't here, I don't think, yet. But you know you're good to go. We learned that we could just switch the denominator with this expression on the left here, the cosine 35. Do you remember that, Siobhan? That we could do this? And just swap them? So then we would get x equals 9 over cosine 35. Siobhan, do you remember that or no? Okay. So that would be JK. 9 over cosine 35. That's the expression that we're looking for. Any questions right there? All right, JD would be similar, so I'm going to skip that. I'm going to leave that for you to do on your own. JD. Yes. That's going to be similar to what I'm going to do down here on this one. Look at CF. Let's do number 17 together. Looking at CF, I'm going to put an X here since I'm about to find CF. the 55 and the 5, those are the only two numbers I've got. So I'm going to use them. So look at these three things, the 5, the 55, and the x. Okay, so Chrissy, which trig function am I going to do? Edgar, coming to you next. Okay, look alive. Tangent. Give me the fraction. Okay, Chrissy says let's do tangent. So tangent of 55 degrees is going to equal what? That's going to equal x over 5. Now, is this something where I'm going to swap? No. I'm not going to swap this time because my variable is on the top. I'm only going to do that swapping thing when it's on the bottom. So, Chrissy, what am I going to do to get x by itself then? So, to get x by itself, we are just going to multiply both sides by 5, like this. That way these 5s are going to cancel out. Okay, so FC, or CF, you might see it as either 5 tangent 55, or they might say 5 times tangent 55 degrees. Either way, recognize it. Of course, if it's a decimal, in the multiple choice, you can put that in your calculator, and that will give you the decimal. So that's number 17. But I actually want to go back to see any problems that we skipped. Okay, looking back at angle Q, number 11. Angle Q. We have the 8, we have the 13. If we focus on angle Q, 8 is adjacent, 13 is the hypotenuse. So which function is that? Hope you said cosine. So cosine of angle Q should equal adjacent over hypotenuse. So if I want to find the measure of angle Q, I would just say that Q is equal to the inverse cosine of 8 over 13. So again, when I want the angle and the other angle isn't given, that's when I use inverse trig functions. So I could put this in my calculator and get a decimal if the answers were decimals. But if the answers are expressions, this is what we would put down. Inverse cosine of 8 over 13. Let's look down and see what else we skipped. Okay, JD. Alright, so JD, let's call this Y. Now I've got the 35, I've got the 9, and now I've got the Y. So ignore the X for now. Looking at the 35, Y is opposite, 9 is adjacent. Opposite, adjacent. Which trig function is that? Hopefully we're saying tangent. Tangent of 35 degrees will be opposite over adjacent. So Y over 9. So how will I get Y by itself? Right, I will multiply both sides by 9 like this. That way these 9s will cancel out. So as an expression, I would have 9 tangent 35. Okay, that would be the expression that would give you JD. And again, they might put a little times in there. You never know, so don't be thrown by that. See what else we skipped. Measure of angle F. Well, the measure of angle F, we can find this exactly. Since they gave us G, we don't need to do tangent, sine, or cosine. The easiest way to find angle F is just to do 90 minus 55. Okay, 90 minus 55. So that's going to be 35 degrees. So we can just put 35 degrees. What else? GF, the hypotenuse here. I'm going to go ahead and put an H on here. That stands for hypotenuse. So ignore the X for now. So, in fact, let's use the 55, not the 35. Let's stick with the angle that they gave us. So, let's just use the 55 and the 5. So, using the 55 and the 5, 5 is adjacent and H is the hypotenuse. Adjacent and hypotenuse. So which trig function is that? Hopefully you were thinking cosine. So the cosine of 55 would be adjacent leg over the hypotenuse. Now, how do I get this H by itself? How do I get the hypotenuse by itself in this case? Were you thinking that we would do the shortcut and reverse the position of these two? I hope so, because then you understand that we will have hypotenuse over here, and on this side we will have 5 over cosine 55 degrees. Now, for this paper I want all expressions, so we're going to leave this as 5 over cosine of 55 degrees. Of course, if I wanted a decimal, I could put all this into my calculator and I could get a decimal. Okay, that is it for part 1 of our review.